In this illustration, we'll be analyzing a given L-shaped accelerating tube. Here the figure shows a tube filled with a liquid which is L-shaped and accelerating horizontally at acceleration A. We are required to find A for which no liquid will fall out of the tube from any ends of the tube which are open. So in this solution, we can analyze the tube as an accelerating reference frame in which liquid is filled. And we already discussed that in an accelerating reference frame, the effective gravity changes to root of g square plus a square. So in this case, if we talk about the liquid in the tube, when g is acting in downward direction and with respect to tube, the pseudo acceleration will be acting in this direction. So this is the effective acceleration on liquid due to pseudo force in frame of tube. This we already discussed. When both A and G are acting, the free surfaces of the liquid get inclined, and when it will get inclined in such a way that the free surface is along the line joining of the two ends A and B of the tube, and liquid will not spill over from any end. So in this situation, as we are given this height as h, this is L, we can consider this angle to be theta. So here we can write, if liquid is not coming out from any end of tube, here we can directly write this implies the value of tan theta should be equals to A by G, which we already discussed in concept, and the same can be written as H by L, and this implies the value of acceleration we are getting is Hg by L. That is the result of this problem. And we can also solve it in an alternative way for this problem, like from end A to B, here pressure is P atmospheric, here also pressure is P atmospheric. So liquid should be at rest in the tube, in the reference frame of tube. So we can write, as liquid is at rest in the frame of tube, we can use Pascal's equation from A to B as, here we can write pressure is atmospheric at an A. If we calculate pressure at this band, it will be plus H rho G, as in vertical direction this A will not affect the pressure. Then again from this point to this point, pressure will be minus L rho A, because opposite to the direction of A, here pressure will decrease, and this should also be P atmospheric. So this gets cancelled out, and simplifying this relation, we are again getting the value of A is equals to Hg by L, which is the result of this problem. And we have calculated it in an alternative way by using Pascal's pressure equation. Here we have calculated it by using the angle theta, which the free surfaces of liquid make in accelerated reference frame.